Hello everybody, and welcome to your next set of video notes. This is Mr. Basil, and let's get to it. So, this is for Learning Target 4.3 at the basic level, and in this video, by the end of the video, you're going to know how to make Bohr models and Lewis structures for elements on the periodic table. Things that you should already know are what are Bohr models, what are Lewis structures, and kind of how to make Lewis structures too, because in the previous video I went over that. And you should also know what valence electrons are. Okay, if you don't know those things, go back to the previous video at the approaching level, watch that, take notes, and come back. So let's get to it. So how to make a Bohr model? Well, there are a few things that you have to be able to know how to do. First of all, you're going to, so how to make a Bohr model. The protons and neutrons are in the middle, or the element symbol goes in the middle, and then from there we need to fill the electrons going from the lowest energy to the highest energy level. From lowest energy level to the highest. However, first energy level, so each energy level holds a little bit different amount of electrons. The first energy level holds 2 electrons, and then the second and third energy level holds 8 electrons. And then electrons like to remain unpaired, meaning like they're by themselves, unless you start filling up enough of the energy levels. So electrons, which again are just E with a minus. Electrons remain unpaired until there are 5 or more electrons. Then they pair up. Okay, so let's see what that looks like. If you don't have your periodic table handy, you should absolutely have that handy for what's coming next. So let's do this for hydrogen, for lithium, and sodium. Okay, hydrogen, lithium, and sodium. So for hydrogen, looking at the periodic table, well, we're going to assume all are neutral unless a charge is stated. So all are neutral unless charge is stated or a number of electrons is given. Okay, assume all are neutral in this video. Okay, in the next video we're going to talk about when things are ions and how to figure all those things too. But for hydrogen, lithium, and sodium, their atomic number is 1, 3, and 11, which tells us the number of protons, and in order for this to be neutral, knowing the stuff from previous videos, the number of electrons needs to be equal to that. Okay, so for hydrogen it's 1, lithium it's 3, and sodium it's 11. Okay. So for a Bohr model, we're going to start, we could put a number of protons and neutrons in the middle. I'm just going to put the element symbol in the middle. And then we have the energy levels that go out from there. And for hydrogen, we just need to put on 1 electron. So we're going to put that in the lowest energy level. So I'm just going to put 1 electron right there. Okay. Sometimes you can draw it like that, or I usually just draw the electrons as dots. So something like that. I'm just going to say this is an electron. Okay, so hydrogen is the easiest one. You saw that in a previous video too. It's just 1 dot, like that, because there's 1 electron in the lowest energy level. Next up is lithium. So lithium, I'm going to have my energy levels going out from there. For lithium, it has 3 total electrons that we want to put on to make it neutral. And so I'm going to put that in the lowest energy level. But remember, there's the 2-8-8 rule, okay? Meaning that there's 2 electrons in the first energy level, and then we could fit a total, or we could fit 2 in the first energy level, and we could fit 8 in the next energy level if we had that many electrons. So in this case, these two fill up this energy level here. So that's when I have to come back and then go to the next energy level. Okay, so 2 in the first, and then the next one goes in the next energy level. Sodium, I'm just going to say Na, and put my energy level circles around that. And I have a feeling that we're going to need more. Let's see if we do more energy levels. So that's why I did 3. So I've got 2 electrons in the first energy level. And now I'm trying to get to 11 total. So I've got 2, 3, 4, 5, 6. And remember, once I have 4 in an energy level, that's when they're going to start pairing up. So I've got 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10. So I've got 10 total, so I need 1 more. Need 1 more, just to note myself of that. But now you can see I've got 2 in this first row, or first energy level. And then I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, they've all been in the spots that they can be in. So the 2-8-8 rule, I've got 2 in the first and 8 in the second, so then I need to do 1 more in the third. Okay, so that's where that one went. All right, so as you can see, that's just kind of the pattern that we go through while we do this. Okay, and so if you kind of follow the pattern here, notice how many valence electrons there are. From, remember from the last video, that's how many are in the outermost energy level. Notice that they all only have 1 valence electron. Huh, that's kind of cool, isn't it? The reason why is because the periodic table is set up to see that in group 1, all of these elements, even if I did potassium, rubidium, cesium, and francium, they would all end up having 1 valence electron. And that's true of all the rows in the periodic table except for the transition metals. So it's worth noting to yourself the following. Okay, so all elements in the same column or group in the periodic table, those are called groups, have the same number of valence electrons. The transition metals are an exception. So when I come over here, these right here are transition metals. Okay, so these guys in group 1 have 1 valence electron. And then in group 2, these have 2 valence electrons. And then we skip the transition metals. And then we'll do a couple more examples here, but these all have 3 valence electrons. If you notice, these numbers right here are the ones that tell you how many valence electrons they have. So 4, 5, 6, 7, 8 valence electrons. Okay, the only exception is that helium has 2 valence electrons. The rest of those have 8. Okay, so let's see if that's true or not. So let's look at silicon. And then let's look at fluorine as well. Okay, so silicon is right here, has 14, and fluorine is right here, has 9. So silicon has Si, and then let's draw the energy levels going out from, ooh, whoa, that was wild, from there. And so then let's check. So 2 in the first row, always. First energy level, that's 2, 3, 4, 5, 6. Oops. 2, 3, 4, 5. So 2, 3, 4, 5, 6 total. But now I need to start pairing up because I have 4 in the second energy level. 6, 7, 8, 9, 10. Now I need to go to the third energy level because I got 1, 2, 3, 4, 5, 6, 7, 8 in that second one. So 10, 11, 12, 13, 14. And going off of what I had just written over here, I predicted that I would have 4 for silicon because it's in column 14. And sure enough, 1, 2, 3, 4. Look at that. All right, now let's do the last one. So fluorine has 9, so I'm going to say F in the middle, and then do my energy levels going out from there. I've got my 1, 2, I go to the next one, 3, 4, 5, 6, 7, 8, 9. So I've got to my total here. Notice that I only have 2 in the first row, and then I can fit up to 8 in that second row, but I didn't need it because I ended up running out of electrons by then. Also, I started pairing up after I got to 4. So now let's double check. So I've got 1, 2, 3, 4, 5, 6, 7. And based off what the periodic table says, it does accurately predict 7 for fluorine. All right, and we're almost done here, but I do want to loop back to the Lewis diagrams. So remember, Lewis models only show the valence electrons. So for hydrogen, the Lewis would be just that. For lithium, it would be just that as well. And sodium, just that too. And then coming over here for silicon, Si with 1, 2, 3, 4. We try to keep them unpaired until we have to start pairing them up. So fluorine would be 1, 2, 3, 4. And then we have to start pairing up 5, 6, 7 valence electrons. Now the valence electrons are going to be really important. So the Bohr models are good to draw those non-valence electrons, the core ones, but in chemistry you'll find that we're really going to focus on these valence electrons for a lot of things that we do. So there you have it. In the next video we're going to talk about ion formation. Thanks for listening, and see you next time.